Yeah, thanks for the introduction. Yeah, welcome to my speech regarding configuration as code and AI to simplify the AutoSAR configuration. So in the last day, we talked a lot about complexity and how to deal with that complexity. And AI introduced a lot of simplification, a lot of efficiency gains actually in the development process. And this presentation is about how we can combine these two trends that we see with the complexity and the AI capabilities to make ECU configuration more simple and more efficient. So let me first start with what changed actually in the development in the last few years. Is the laser pointer? Yeah. I just can see it. Okay, on the left-hand side, we see the typical functional-oriented architecture, and what we saw in the presentation of Xiaomi. We have now this trend to integrate multiple ECUs into either zonal or HPC, and this also means that we have to integrate all the functions, all the applications into one single ECU, and that adds a lot of complexity into this ECU. And if we have a look at what this means for the configuration, I want to ask a question to the audience. What do you think, how many AutoSAR configuration attributes we are typically seeing in such a zonal controller? Do you have any idea, just a rough number, just a gut feeling, how many attributes we currently see in zonal controllers? 20,000, yeah? Anyone more? 1 million? Yeah, that's actually a quite good guess. So roughly 1 million AutoSAR configuration attributes, that's what we currently see. So these are not made up numbers actually. So these are real numbers that we took from a real zonal project. And I want you to remember this number because we need it later in the presentation as well. So the question is, can we use AI to tame this AutoSAR configuration beast? So let me have a look at how AI already transformed the way we develop software today. So right now, AI is evolving very quickly, and it already can support in a lot of areas of development. So it can be used to analyze large code bases, generate code, assist in debugging and testing, and also automate repetitive tasks, so help in the CI/CD workflow. So the solution seems simple. So why not use AI to assist in the ECU configuration? Now let me look at some options how to actually implement this. So the first one is what we call vibe configuration. The idea of what we call a vibe configuration with AI is that we directly let AI interact with the AutoSAR configuration model. So at first, this seems like a very sensible approach. So the AutoSAR configuration model is well structured. It's XML based, so it's machine readable, machine friendly, and it follows a very strict format. So therefore, AI works very well on structured text. so therefore it should be a really good match. But yeah, in reality, it's a little bit different. So the first problem with this approach is the complexity of the AUTOSAR configuration model. So when we look at the configuration, we see deeply nested containers and a lot of references between these containers. We have multiple abstraction layers, and to actually access one parameter, you have to traverse through the RXML tree. And second topic is RXML is basically a graph structured data with very strong constraints. And the AI models are optimized for text reasoning, but not to follow these graphs. And last but not least, we have an inherent contradiction. So you know that LLMs work probabilistic, and on the other hand, the AUTOSAR configuration is quite binary. So even if you have just a small mistake, it's not working. So that's an inherent contradiction of this approach. And what this means is the coding agents or the LLMs quickly get lost in large configurations, like we can see here. So they are simply losing track. And therefore we came up with a different idea, and that's what we call configuration as code. So the general idea is that we transform the AUTOSAR configuration model into a code model, which is then executed to actually alter the configuration. This is beneficial because right now all the AI activities of the big companies, they are really focusing on these coding agents. So there were big improvements in the last few weeks and months. So they can already understand large code bases. They can do automated refactoring and also automatically generate code. So by going with this approach, we can also work on pretty large configurations. I hope you still remember this 1 million AUTOSAR attributes. So we really did this on such a configuration, and it was still working. So what are the benefits? So representing the AUTOSAR configuration as a code model, it helps to reduce the context window. Next one is we already have embedded validation. So as we compile the code, we have implicit checks. And we have modularity. So that means we can reuse the code, and we have a structured architecture, and both things help to get the most out of the coding agents. And we get reproducibility, which means we use the coding agent to generate code, but once it's generated, the execution is reproducible. So that means you don't have the issue that every time you run this step, you get different results. And last but not least, with this coding approach, you can use Git with all the different merge features, since it's the normal development flow as you work on code with this. And if we look at our coding agent, he's very happy now because he knows he's got a very strict workflow and a very good plan to follow to navigate through the AutoSAR configuration jungle. So let's see how a practical implementation could look like. So we actually went with a layered architecture. So on the first level, we have the really low-level abstraction. So basically a one-to-one representation of the BSWMD model. Then on the second level, we have an abstraction of this low-level layer. In case there is an update of the AutoSAR version, for example, we can use this layer to hide any incompatibility. Sorry, complicated word. And on the third layer, we have a high-level abstraction. So this can be used to implement really complex abstractions. Things like I want to move some basic software components from one core to another. And this can be then done in just one AI prompt. And the same thing is available as a user extension. So the red parts are actually the core of this product, of this as code abstraction. And the blue part are extension points, because especially on this higher level, on this layer 3, we expect a lot of customer and use case specific adaptations. And the architecture reflects this so that customers can implement their own abstraction depending how the teams actually work. Oh, sorry. Okay, now let's have a look how the workflow actually looks like. I start without a coding agent. So here on the bottom, I don't know if you can see it, but there's our developer actually working on the configuration code in a manual way. Then the developer would compile the code, execute the code, introduce it to the configuration tool, and then the configuration tool would do the validation. In case there is an error, the software developer would fix that and redo it again, and then the configuration tool would generate the source code files to be integrated in your embedded product. So if we introduce a coding agent now, the develop workflow is still the same, but it's now AI assisted, which means our software developer does not really work on the configuration code, but prompts a coding agent to work on that code. So the coding agent would modify the configuration code called the compile step and retrieve the results of the compiler output, maybe does some modification, compiles again until this step is done. And this is a quite important pattern actually. So we all know that LLMs are probabilistic. So it's quite important to do this validation steps in an early phase to implement this feedback cycle. Because otherwise, let's say you would run the coding agent for half an hour, hours, you would waste a lot of tokens, and in the end, you would see, okay, it's not coming to a successful execution, you would stop it, do the modification, and then rerun it again. And with this early feedback cycles, you can really save tokens, which I guess gets more and more important in the near future. So after the successful compilation, also the coding agent would do the execution of the configuration as code. And what we implemented here is what we called structured aggregation, which means we enrich the output of the execution so that it's really digestible by a coding agent. So in case there are errors, it can really detect, okay, that's the source of the problem. I can modify the code again and re-execute the cycle. And the same thing actually happens for the validation step. So also the AutoSAR configuration tool puts out some validation errors maybe. Also this is integrated into this aggregated log, and again feedback to the coding agent. And another topic that needs to be covered is actually what we call the log viewer. In all these steps, the human needs to be in the loop. So it needs to be transparent for the software developer what the coding agent actually did. And that's why it's very important that you have like filtered views on the logs, so that you can determine, okay, the coding agent followed actually the steps I wanted to do, and I'm able to easily select critical parts of the log, because the coding agents are very good in producing a lot of output, but you as the human are actually the bottleneck. So it's very important that you can filter this information so that it's easily to understand what happened, and that you control that. So to sum up, ECU configuration is really one of the biggest challenges that we are facing, especially with this integration of or consolidation of a lot of ECUs in the zonal controller. So we learned yesterday from Joachim that setting up such an ECU takes weeks, and that's really a big part of the integration time. And we also learned that direct AI interaction with the RxML model is difficult. So that was actually also mentioned yesterday in the Hyundai AutoEver presentation. So I'm glad you came to the same conclusion. So it seems we are on the right track here. So the problem is simply the structural complexity, the context limitations that we have in the LLM models, and the strict consistency requirements of the AutoSAR configuration. Yeah, and we see configuration as code really a practical path forward, also to move AutoSAR or the AutoSAR Classic platform especially into the next generation of vehicles, because it's making the AutoSAR configuration AI compatible, developer friendly, because our developers are used to work with the code, and really scalable for large platforms that we will see in the future. So maybe even bigger integrations of zonal ECU. So I talked to Marius from NXP today. So they have microcontrollers with up to 150 cores now. And you can imagine that the complexity really explodes with such microcontrollers. And that's a practical way forward to help foster with this complexity. So combining as code configuration with AI assistance enables really faster ECU integration and faster release cycles. It reduces the engineering effort, and it also increases the configuration quality. So the idea is quite simple. So the AI provides the intelligence, and the configuration as code provides the structure to work on this. And with this, we can go from this situation, so missed deadlines, to this one, our happy software developers meeting the deadlines by the help of coding agents and configuration as code. And with that, I want to end my presentation, and I'm happy to hear your questions.
Thank you for your great presentation. And it's good that the problem we observed is the same. By the way, the code as a configuration, it's a little bit difficult for me to understand. Is it meaning you are introducing another syntax, such as AR text, or the other way?
Mm-hmm. Yeah, that's actually a good question. So we're explicitly don't went with a specific syntax. So in our case, we are using Kotlin code to represent the configuration, because if you introduce specific syntax, you have to make the coding agent aware of this, and by using a standard programming language, no matter what it is, coding agents can really work with that, and you're invited to see our presentation at the Vector booth to see it in action. So it's what I presented today. It's not just a concept. Like I said, it's working on really large configurations, and the colleagues are happy to show that to you.
Thank you.
This is Fanny from ST Electronics, and my question is here for your. It's very great to have these AI tools, and this tools is in your toolbox as a Microsoft toolchain, or it's additional one and on tools, and also here. We think the concept is the same, so these tools can also be valid for the MCore configuration or not?
That's also quite good question. Just to make it clear, so the coding agent is not part of our offering. So you're using the coding agent that you already deployed at your company. So whether it's DeepSeek, Kimi, or whatever. And if you remember the layered architecture, so the BSWMD representation, the layer 1. To do the MCAR configuration, for sure, it makes sense also to have it as text or as code representation of this. So we have actually converters to which just take the BSWMD file. Yeah, it's quite simple to also apply this to your MCARs.
You had another question?
I have a question. Traditional configuration is designed for human use, so we need a beautiful AI UI to configure all the parameters and keep this data in AI XML files. But but AI agent, AI tools is not good at dealing with the XML file. So why we don't change all completely change this process and directly use AI to generate code and ignore the middle, ignore the XML files. Maybe we can choose another input format to AI to tell AI what what the user configuration is. What do you see?
Yeah, that's yeah, quite good idea actually. So we're still, let's say, going this compatible way by also generating our XML files, which can be digested by the configuration tools. Simply because some customers still want to use a graphical user interface, let's say, and they want to review maybe also the output of the S code execution. So we still want to provide this path, but you are absolutely right. It would be also possible to just take this as code representation of the configuration and then directly generate from this. Yeah. Would be also possible.
Yeah, hello. I have a question for your workflow. So basically, I have two questions. One is I see the developer now give some prompt to the AI agent. So I'm not expert, but what is in this prompt? It is some requirement or features, or it's just some configuration descriptions? I'm not sure. So, and this is the first one. And second is for the whole workflow in the near future or realistic target, it's workflow completely automatic or it's just a AI in loop and still the developer need to check or validate for every step, every output. Yeah.
Okay. So regarding the first question, it, let's say, depends what you want to change. So it can start from, I want to modify a very special or very dedicated AutoSAR configuration attribute. This would be one option. But with this layered architecture, with this abstraction, it's also possible to provide very simple prompts. So like the example I mentioned in the presentation, we implemented abstraction so that you can move basic software components one core to the other in just one prompt, basically telling the coding agent, hey, I want to move the Ethernet stack without specifying which components actually the Ethernet stack includes, from core 0 to core 1. So that would be, let's say, the bandwidth that we see. So just making small modifications or really implementing large and complex operations in one prompt. And maybe you can repeat the second question, sorry.
Sorry, second question is the whole workflow in near future, the realistic target is to make it completely like automatic, or it's just some, like you mentioned, AI assistant. And yeah.
Yeah, okay, yeah. Yeah, I mean, you're free to do both. So the idea is really to automate it. So you can run these automated loops independently, and you as the human in the loop, you can review these logs. And what you showed, or what was shown in the AutoEver presentation, for sure you can also extend this feedback loop by software in the loop, hardware in the loop tests, so that you have greater confidence in the output. But the good thing, okay, yeah, time's up. Maybe just one last sentence. The good thing about having this intermediate as code representation is once you have this generated and reviewed, you can run it over and over again, and it's completely reproducible. Yeah.
I've promised one last question here, maybe a quick one. Thank you.
So,
yeah. Is the code you are talking about actually a code representation of the complete configuration, or is the code we are talking about more like small API instructions that call the configuration tool and the actual single source of truth for the configuration is inside of the configuration tool?
no, it's really the code basis. That's the single source of truth. Yeah, thanks for all the great questions and your time.